Okay, for these examples, we're going to look to determine the equation of the conic described in standard form. Okay, so here we have an ellipse, and we know the center of the ellipse, we know a focus, we know a vertex. It can certainly help us out to plot our ideas. So we have our center at -1, +2. So x -1, y +2. We have a focus at 0, +2, right? So we know that if I go over, right, if I go over 1 unit to the right, I have a focus. And if I go 3 units to the right, at 2, 2, then I'm going to have a vertex. So that means that if I go 1 unit to the left, I'll have a focus. And if I go 3 units to the left, I will have a vertex. So I know the general shape, of my ellipse is going to be stretched horizontally because I noticed that the y values for all of these, are along the horizontal line, y equals 2. So how can we determine our equation for our conic? Well, we know that the distance from the center to the vertex is the value for A when we are on our major axis, and that's going to be a distance of 3. We need to figure out the distance of B, but we also know the distance of C is the distance from the center to the focus, and that's a distance of 1. Right? We know that our relationship is B squared equals A squared minus C squared, right? Which would be 9 minus 1, which is 8. So that means that B is the square root of 8. And with that information, we can get our equation. And our equation would be, right, x plus 1 quantity squared plus y minus 2 quantity squared equals 1. X is stretched along the horizontal, so x gets the larger denominator, 3 squared, and y gets the smaller denominator, which would be the square root of 8 squared, which would be 8. And so there we have the equation in standard form for our ellipse. For our parabola, work is going to be slightly different. For our parabola, we know a focus, which is the 0.36. All right, so I'm going to go ahead and say, hey, there is my 0.36. That's my focus. And I also have a directrix, y equals 4. Well, y equals 4, as compared to my focus, I know is going to be below my focus, which has a y value of 6. So that means that my vertex is going to be halfway between my focus and my directrix. And I know my parabola will therefore open upwards. So what does that mean for me? That means that I know that the form of my parabola that's opening upwards is going to be x minus h quantity squared is equal to 4p times y minus k. So I need to be able to figure out my vertex. I know that my vertex has the same x value as my focus, which is 3, and it is halfway between my focus and my directrix, which would be 1 unit, and 1 unit down would be therefore 5. Right? And I know that P is going to be equal to +1 because the focus is above my vertex. So what does that tell me for the equation? That tells me the equation is going to be x minus 5 quantity squared is equal to 4 times x minus 3, x minus the x value, so x minus 3 quantity squared, and then 4 times y minus 5, the y value. And once again, that's because the p value is equal to 1. There we have. Now, we also have here a hyperbola, and here we have a circle, right? So let's do the circle first because that tends to be easier. So we have a circle with a center and a radius. I know the general form of my circle is x minus h squared plus y minus k squared is equal to r squared. So for us, this would mean x minus h squared plus y minus k squared equals 21. And that's it. All right, so a fairly simple one for that. And now we have our hyperbola. For our hyperbola, we know where our center is, we know the value of A, we know the value of C, and we have a vertical transverse axis. We have a vertical transverse axis. What that vertical transverse axis tells us is from our center, right, we're going to have a center at 4, 2, right? That means that our vertical transverse axis is x equals 4, which also means that our hyperbola, whatever it happens to be, is going to be opening upwards and opening downwards. Okay? Because we're opening upwards and we're opening downwards, I know that the general form of my equation is going to be y minus k squared over a squared minus x minus h squared over b squared is equal to 1. That's going to be my general form. And the relationship is c squared is equal to a squared plus b squared for our work with hyperbolas. So that means that 16 is going to be equal to 1 plus b squared. So that tells me, therefore, b squared must be equal to 15. And I know my center, so I have enough information now for my hyperbola. And that is y minus 2 quantity squared all over a squared, which would be 1, minus x minus h, so x minus 4 quantity squared, all over b squared, which in this case would be 15, equals 1. And that's the equation for my hyperbola. So notice the difference in A and B. Notice the difference in A and B for hyperbolas as compared to ellipses. For hyperbolas, A is always underneath the positive, B is always underneath the subtracted, right? So y squared minus x squared. So A squared goes with y, B squared goes with x because it's y squared minus x squared. However, for an ellipse, right, always goes for a squared with the larger number. Always goes a squared with the larger number. So there we have our equations.